Welcome to the course on testing in Laravel. In this module, we'll explore the fundamentals of software testing and how it applies to Laravel applications. Let's start with the basics. What is testing? Testing is the process of evaluating a software application or system to ensure it meets specified requirements and functions as expected. But why does testing matters? Testing is an essential part of the software development lifecycle. It helps identify bugs, errors, and vulnerabilities early in the development process, reducing the risk of issues in production. By testing your Laravel applications, you can ensure reliability and stability, improve code quality and maintainability, reduce the likelihood of costly errors and downtime, build confidence in your application's functionality. Testing frameworks provide tools and utilities for writing, running, and managing tests. In this course, we'll primarily focus on PHP Unit, the de facto testing framework for PHP, and Laravel's built-in testing helpers. Test-driven development (TDD) is a development methodology where tests are written before code. TDD helps ensure code correctness, maintainability, and test coverage. In Laravel testing, we often encounter two primary types of tests: unit tests and feature tests. Understanding the differences between these types of tests is crucial for effective testing strategies. Let's start by exploring unit testing. Unit testing focuses on testing individual units or components of code in isolation. These units are typically small, such as methods, functions, or classes. Characteristics of unit testing include testing a specific piece of functionality in isolation, mocking dependencies and external interactions, fast execution time, granular coverage of codebase. Examples of unit tests in Laravel include testing model methods and relationships, testing service classes and business logic. Testing helper functions and utility classes, mocking external services and dependencies. Now, let's shift our focus to feature testing. Feature testing, also known as integration testing or end-to-end testing, involves testing the behavior of entire features or functionalities within an application. Characteristics of feature testing include testing multiple components working together, emulating user interactions and workflows, slower execution time compared to unit tests, testing real-world scenarios and user journeys. Examples of feature tests in Laravel include testing HTTP endpoints and routes, testing form submissions and validation, testing authentication and authorization flows, testing API integrations and external service interactions. When deciding between unit testing and feature testing, use unit tests to validate individual units of code in isolation. Use feature tests to validate end-to-end functionality and user workflows. Strike a balance between unit and feature testing to achieve comprehensive test coverage. In conclusion, unit testing and feature testing are both valuable testing methodologies in Laravel. Understanding their differences and when to apply them will help you build robust and reliable Laravel applications. In a fresh Laravel project, you'll find a feature directory within the tests directory. Inside the feature directory, you'll see a sample feature test file named exampletest.php. This test file contains a basic example of a feature test written using Laravel's testing framework. It typically includes tests for routes, HTTP requests, form submissions, and other feature-level functionality. In the same tests directory of your Laravel project, you'll find a unit directory. Inside the unit directory, you'll see a sample unit test file named exampletest.php. This test file contains a basic example of a unit test written using Laravel's testing framework. It typically includes tests for model methods, service classes, helper functions, and other units of code. Let's take a closer look at the content of the exampletest.php files in both the feature and unit directories. In the feature test file, you'll see tests that interact with your application's routes, make HTTP requests, and assert responses. In the unit test file, you'll see tests that interact with specific units of code, mock dependencies, and assert method behaviors and return values. Now how do we run the two tests files that are already in our application? We can do that using PHP artisan test, and the two tests has passed. In the feature test we are just checking if the root is returning a 200 response, and in the unit test one we are checking if true equals true. Now let's start by writing real tests. First I made CRUD operations for the posts so we can see, add, update and delete posts, and these are the roots and the controller. It is a simple controller and roots, and with just those functions. Now let's go and try to test our application. Let's start by testing the index root. In this test, we're checking whether the index root returns a status code of 200, indicating a successful response. As you can see in the code, we use the thisGet method to simulate a GET request to the index root. Then, we assert that the response status code is equal to 200 using the response assert status 200 method. And now if we change the index to some root that is not available, we will get the 404 error and that the root is not found. Now, let's move on to the store root test. This test is used to verify the functionality of the post's root when handling post requests, typically used for creating new resources. In this test, we're sending a post request to the post's root with some test data, including a title, body, Once again, we assert that the response status code is equal to 200, indicating that the request was successful. But we got an error with our test. Let's see why. We forgot to add user ID to the data, and we wrote the get instead of post in the method, so let's fix those errors and try again, and we have added the user ID to the controller, and now our tests are running and they are all passed, and that's great. Now we know that the root is returning a 200 status code, but we don't know if the post is added to the database or not. So we will add another line into our test, and that is assert database has. It takes two arguments. The first is the table that we want to check, and the second is an array of the data. This function will check if the post that we passed is in the table that we specified or not. And now let's try and run our tests, and our tests has passed and the post is in the database. Now let's try to make a test for the delete root. We will just call the delete root and pass an ID in the URL, and then we will assert status 200, and now let's go and try it. We got an error because the method is wrong, and when we fix it everything should be working fine. Next we need to test the authentication, so let's try and add the auth middleware to the index root, and now let's try again. And we will get an error because the root is now protected and we are not logged in, and I didn't make a login root, so we got login is not defined because it should redirect us to the login page. So how do we act as a logged-in user inside our test? We will first use the user factory to create a user, and then before the get index we will chain the acting as method. This method will take the user as an argument, and now we will act as a logged-in user. So now if we try to run our tests, the tests will be passed and everything is working just fine, and that's great. Now we have tested for authentication, but what if we want to test for roles, like if we have an admin and if he has access or not? I made an is admin column in the user table, and I have made an admin middleware, so now let's change the middleware from auth to is admin, and then let's try again. and we will get an error and the test will not pass because we are acting like a normal user, not an admin. Now how can we make the user an admin? We can pass it the isAdmin true inside the factory create method, and now the user that is created from the factory is an admin, and if we try again and run our tests, the test should pass and everything is running fine. Now how can we test our blade pages if it contains the data that we want? Let's say we have a blade page and want to see if it contains the word body inside of it. We will use the assert function to do so. It takes the term that we want to search for and it searches for it in our blade page. If it is found, the test is passed, and if not, we will get an error. So let's try and run the test, and it will find the word body. Now let's try and search for something that is not there, and we will get an error, and that is how assert works for the blade files. Now when we run our PHP artisan test, we are running all the tests that we have in all of our tests file. But what if we want to run only a single test function? We will use the filter flag inside the command, and then we will write the name of the test function, and now only the test function is tested. Now what if we want to test all the function inside a single file? We can do so by passing the name of the file in the filter flag, and now all the tests inside that file are tested. Now let's try and test our validation rules. I have made a store request for the store function and made everything required, so let's try now and remove the body from the data that we send and see what we will get. And if we run our tests, we will get 302, not 200, and that is because we don't have a body. But what if we want it to be a better response and we want to understand what is the real problem? We can add post.json instead of post, and now we will get a JSON response with the validation error that we have, and that is the body is required. Now let's try and edit the assert status to 422 to make sure that that is the error code that we are getting, and that's how we can test our validation rules and if they are working correctly or not. Let's try different scenarios. If we remove the title also, the test will be passed, but if we don't remove anything, it will not pass and it will return 200 status code, and that means we don't have any errors in the validation. Now let's make sure we are getting a JSON response. We will try to use the index URL. The function returns a response JSON, so let's go and test the function if it is really return JSON or not. We will edit the test function with the index URL and remove the has database and the data, and we will use the get JSON instead of post JSON, and we will try and run our tests. And our tests has passed and we are getting a JSON response, and that's great. Everything we have learned in this course is about PHP unit test, which comes with our Laravel application, but now let's learn something more advanced and better, and that is Pest. But what is Pest? Pest is a testing framework with a focus on simplicity, meticulously designed to bring back the joy of testing in PHP. Installing Pest PHP testing framework is a simple process that can be completed in just a few steps. The first step is to require Pest as a dev dependency in your project by running the following command on your command line. Secondly, you'll need to initialize Pest in your current PHP project. This step will create a configuration file named pest.php at the root level of your test suite, which will enable you to fine-tune your test suite later. Finally, we can run the test either by using vendor bin pest command or by just using the simple PHP artisan test that we already use. And now, after we have installed everything, let's make a new test file to explore Pest. We will use the PHP artisan make test command to do so. This file by default will be considered as a feature test and will be in the feature tests folder. Now let's go and explore it. It is a simple file that has the test function first, and it has two parameters. The first one is the name of the test, and here it is example. And the second is a callback function, and inside of it we will write our test. Now let's go and try to make a real test inside of it. Inside the callback function we can write the same tests as the normal tests that we did, so let's just copy the test that we already did and use inside the callback function, and let's just change the name and then try to run the tests. And the tests are all passed and everything is working fine. But why did we use Pest if it is the same as the normal tests? Now let's see what are some of the advantages of Pest. First, we can chain multiple functions together so we can make our test shorten and cleaner. To do so we will delete the variable response and just chain the assert status to the get method, like this, and now our code is simpler and cleaner. Let's try to run our tests and everything is working fine. What are other advantages of using Pest? We can use the before each method before the test function. Inside this method we can define a new user using the user factory create, just like we were doing inside the test function, and now we can use the user variable everywhere inside our test file. So now we can delete it from the test function and use this user instead, and that will make our test function shorter and more readable. Now let's go and try to run our tests again, and everything is passed, and that's great. Now let's go and explore the pest.php file. In the end of the file we can make a function to make our code even more cleaner. We can make a function that, for example, create a new user and then call it inside our test file when we need it, and now we can make our code even shorter. Let's see how we can do that. Let's make a function and call it create user. And inside of it we will use the user factory create to make the user, and make it return that user. Next, if we go to our test file we can delete everything in the before each method and just assign this user to the create user function, and that's how we can do this to make our code shorter and better. And now if we try to run our tests everything should be working just fine and all our tests should pass. We can also make the function take one argument from type boolean, and let's name it as admin. And now when we want to call our function we will pass it true if we want him to be an admin and false if not. Let's try different scenarios and see what we will get. Now let's try a new thing, and that is the expect to be functions. To try them first we need to test on the store method to store a new post. And after we have copied everything, in the end we will get the latest post in the database, and that means the post that we just created, and we will use the expect to be methods using it. The expect method will take the title of the post as an argument, and then we will chain the to be method to it and pass it the data title. Now our test will check if the expect data has the same data as the to be data, and if it is the same it will pass the test, and if not we will get an error. Using this way we can check if the post that we just added to the database is inside of it or not, and we will make it for the title and body and then run our tests, and everything should pass. There is a lot of methods in the Pest documentation. You can check them and test them on your own. I have explained some of them and you can go the docs and check them, and if you got any question leave a comment down below. Next we will talk about TDD and talk about it a little. Now we're diving into the world of test-driven development, commonly known as TDD. It's a software development approach that has transformed how developers write code and ensure software quality. But what is TDD? TDD is a software development process where tests are written before any code. It emphasizes the creation of automated tests to define desired behaviors before implementing the functionality that fulfills those behaviors. The TDD process follows a simple but strict cycle called red-green refactor. Red, write a failing test that defines a desired improvement or new function. Green, write the minimal amount of code necessary to pass the test. Refactor, refine the code while ensuring that tests continue to pass. Now what are the benefits of TDD? Improved code quality. Writing tests first encourages better design and cleaner code. Documentation. Tests describe what the code does, serving as live documentation. Confidence. Changes can be made without fear of breaking existing functionality. And finally, efficiency. Helps catch bugs early, reducing the cost of fixing them. TDD isn't about testing, it's about design. When practicing TDD, you start by thinking about how to test the functionality, which in turn requires you to think about the design of your code. It encourages small, incremental changes, which lead to more maintainable and adaptable code. There is two common misconceptions about TDD. The first one is that it is only for unit testing. While TDD is commonly associated with unit testing, it can be applied at any level of testing. And the second, that it slows development. Initially, it might seem slower, but it often speeds up development by catching bugs early and reducing time spent on debugging. Now what are the challenges in adopting TDD? The first one is the learning curve. It requires time and practice to become proficient. The second is legacy code. Applying TDD to existing codebases can be challenging. And finally, team adoption. Success with TDD requires buy-in from the entire development team. Now let's talk about some tips for getting started with it. Start small. Pick a small, new feature or bug fix to apply TDD. Practice. The more you use TDD, the more comfortable you'll become. Seek feedback. Code reviews and pair programming can enhance your TDD practices. And finally, TDD is more than a development technique, it's a mindset. By embracing TDD, you're committing to a high standard of code quality and maintainability. Remember, the goal is not just to write tests, but to think about how your code will be used and to design it accordingly. And that's it for our testing course. If you like it and want to support the channel, check the Buy Me a Coffee link down below. Thank you for watching and see you in the next courses.